Okay, so developing data-centric architecture with GIST. Here's our team. We're going to talk about how to use GIST to create enterprise ontologies and get started using GIST on your own. Use GIST to connect domains across your enterprise and find out more about GIST. Also, how to get involved in the GIST community and contribute to the evolution of GIST. So we'll start with using GIST to build an enterprise ontology, and then look at case study and talk about how to get more involved. So part one, let's take a real world example. We'll have to set the stage a little bit though. Here's a process for creating an ontology or extending an ontology. First up is identify an area for improvement, which would be your project domain, and it can be almost anything. Rebecca's going to talk about that later. Identify the main concepts of the domain, and we use a diagram called a partee to capture that kind of information as just an initial way to say, here are the main concepts. Define questions the data should be able to answer, which are competency questions. And then you can use the partee and the competency questions to extend the ontology and the taxonomy and also identify data sources. And the process is iterative. At each step, you'll learn things and you incorporate those into previous steps if you need to. So what is a partee? Partee for a house would be a little sketch in building architecture. A sketch like this is used to capture main features and guide conversations. You get your ideas down on paper, and then you just start refining it until you have a blueprint. And if you want to know more about the rationale, here's a link about what a partee is and why is it important from the perspective of building architecture. So in ontology design, you can do kind of the same thing. You can create a sketch. In this one, we have a person who's got some kind of condition that's diagnosed as a disease, and we may have some treatment defined. So you capture some of the main concepts, guide conversations, keep it informal, and again, refine it until you have an ontology. So how about why we use a partee? Partee helps you a number of ways. It helps you collaborate with subject matter experts, focus on the correct areas to make sure, rather than diving in the details early, you're really focused on the big objectives, see the overall structure that resolves many of the problem areas, and see integration opportunities. So a caveat while you're doing this is do not assume that the existing way of thinking about the data is correct. So if you start just by looking at existing data, you may draw the wrong conclusion because some of the existing data structures may be the result of compromises made in the far distant past. So you can use a partee to hypothesize, to discuss, and determine what must be true about the domain. For competency questions, competency question is a functional requirement that the knowledge graph needs to be able to answer. And an example would be, do I have sufficient resources to meet forecasted demand? A good competency question is non-trivial. Being able to answer that question should have value for the business. Typically, it's difficult to answer using existing applications, and it needs to be specific enough to have a clear answer. So also, somebody needs to know where the data is, and frequently that's from multiple sources. And having competency questions helps establish the project scope and success criteria. And typically on our projects, we try to have 4 or 5 competency questions. And although those are the questions that say, okay, have we delivered what we intended to, typically you can answer a lot more questions than just the competency questions once you get the data in place for those. And then we're going to use that to extend an ontology. At the top is a Department of Transportation enterprise ontology that originally started with GIST, so it's an extension of GIST. It just has things like organization, address, or location, but you'll see things that are also specific to Department of Transportation, like a roadway or a roadside feature. And then if you get into a more specialized area like fire hydrants, you may have things like water flow or adjusted lane miles as a way to identify a location. So that would be a subclass of location. And then finally, you have a data mapping from relational data to the extended ontology. So something like water flow might be called GPM in a relational database. All right, so we have several parts there. The party, the competency questions, and the idea of extending an ontology. So let's try this methodology out with a hypothetical scenario. If we're looking at cybersecurity vulnerabilities, you could say, oh, well, my company uses software that has this vulnerability, and if some quote bad guy uses an attack pattern to exploit that vulnerability, I may suffer some damage. So this might be something that would be an initial, just put it on paper, put some stuff on paper and start thinking about it, kind of picture. If you're familiar with this area, you probably see all kinds of things missing, or what's going on here. And we see a little bit of refinement going on in the lower right corner. The damage could be potential damage or it could be actual damage. So if you're talking about actual damage, you'll notice that there's no actual attack on the picture. So that we'd want to add that. When you have the discussions about, okay, what do you see in the picture? What's missing? That sort of thing. Somebody might say, oh, well, software, is that software that I've purchased, or is that software that I've built? And maybe those are two different flavors that you'll want to consider. You also might have someone say, oh, well, a vulnerability could also be a gap in my process that leaves things open for mischief. So anyway, very, very simple picture just to get you started. We like to keep it informal. And so having sort of set the stage a little bit with a party, we start to look at competency questions and say, okay, let's focus on a piece of this. So let's try, what software vulnerabilities do I have that are currently listed as, quote, active in the wild? And that means something in the cybersecurity community. It means that I have software from a vendor that a lot of different people are using, and some of them are getting that vulnerability exploited. So, and also, what can I do about these vulnerabilities? So given that as a competency question, and let's add one more. Let's say I want to be notified if something is not currently active in the wild, but tomorrow, or the next day, there are attacks that are known about. I want to be informed. So where might the data be? In our picture, we said, our party, we said, well, my company is using some software component, and maybe you have that data in software asset inventory. And the software component has a vulnerability. You might be able to detect that with a security scan. And finally, the vulnerability has a status and remediation that you might be able to determine by looking online from the cybersecurity community. There are several sites like CVE.org. CVE is Common Vulnerability and Exposure, and CWE is slightly less specific weakness, and CISA keeps track of active exploitation of vulnerabilities. So again, this process is iterative. You may find out that, oh, well, you know, my security scan tells me which piece of software has the vulnerability, so maybe I don't need to go dig out information from my software asset inventory. And the CISA.gov would have the information about the status, so I would probably need that if I wanted to get alerts. But, you know, maybe my security scan tells me what the remediation is. So you might not need all this data, but this is just a first cut at identifying where the data might be. Okay, so if you're going to create a cyber ontology that includes the things we've just talked about, import gist, and that way the work that you do to create an ontology for cyber can integrate with work that you do in other areas later on. So we'll start by importing gist. Look for gist concepts that can be reused. In this case, my company is an organization. The software component, like version 2.10.3 of some piece of software, would be a product specification. And the type of information you can get about remediation online is text. So that's content, and it would be content about the vulnerability. So you can use categories to create simple distinctions. For example, the status, again, this is information you get online, which would tell you what's the status of this vulnerability. Is it currently being exploited? What's the detection method, and what's the a level of exploitability? So extending gist would involve either creating subclasses or creating new top-level classes if necessary. And in this case, vulnerability probably doesn't fit neatly under anything in gist, so that would likely be a new top-level class. And then you may need some new subproperties or new properties. So my organization uses this product specification, and let's see, past vulnerability would be the other one. So now you've aligned your party with gist. And you'd want to cycle back to what you've learned so far, see if this all makes sense, and maybe refine the party and so forth. And you also might learn more about how things actually work as you start to look at the data. And to validate the ontology, you really need to load real or realistic data. Sometimes you run into surprises. We get the real data, you find things that you maybe didn't think about the first time through. And so there's our little diagram. We started off with that very rough sketch in the party, and we ended up with this diagram that shows how the pieces fit together.